tyFlow Basics, MultiFracture Operator Quick Start Tutorial. G'day everybody, it's Rob from Fireflight Photo. Today we're going to be looking at the MultiFracture. It comes as an operator and a modifier. Pretty well they're identical, except there's a few settings available in the operator that's not available in the modifier, and maybe vice versa, some in the modifier that's not available in the operator, but that's just minor differences. We'll just be working with the MultiFracture modifier because it's going to serve all of the purpose for a quick start tutorial. We've got a box that's been turned into an edit poly that has material ID 1 assigned to all of the polygons. So to fracture this object, all we have to do is drop the modifier on. This mesh looking thing, that's a representation of the fracture mesh, and the yellow is intersections. But for now, we're just going to turn off those indicators, visual indicators, and look at the box, and I'm going to drop a tyPush modifier on here so I can separate all the elements, and I'm thinking something like 300 will do the job. Alright, so without us having done much except drop a MultiFracture on and a push modifier so we can see what's going on, we can see that we've fractured this cube in just a couple of steps. The MultiFracture modifier has 8 different modes. Towards the end of the tutorial, we're going to concentrate on this Verono, but a lot of the settings we're going to be talking about will apply to all of them. This is just a quick start, but by the end of this, you'll be on your way. Alright, so we're just going to quickly do a short video on each of the 8 modes. It won't cover the in-depth settings, but it'll kind of quickly show what each mode does very quickly, and then after that we will go over some of the theory and main settings that apply to all the different modes, and we'll get you going on fracturing. If you don't want to see each of the 8 modes, I will just put a time jump to start the theory. So here we go. Alright, so in this quick start guide, let's just take a look at the MultiFracture text map. We're not going to go into it in any detail other than using a texture map to make your fractures. So I've just gone in and created this 1200 by 1200 pixel black and white. The black is going to be the objects, the white is going to be where the fracture lines occur. So we come in here, I've set up push to push away the objects. I've set up tyPush so that any fractures will kind of try to move apart so we can see them and make it easier to visualize what I'm talking about. So let's do our MultiFracture, and we'll put it below here, and we can see this is the default, but we actually want to show you what a text map does. So we come down here to text map fracture, we go over here to the text map rollout, we add the map that we created, so we have to do a bitmap, and we go in here and we pick our text map example bitmap, and we can see right now here tyPushes and pushing them apart, and the object is actually too small, the texture map, so the fractures are staying within the bounds, which means they can't move apart, and the fractures aren't actually going to the edges. So we can go in here and grab the gizmo, which is now going to be the gizmo for the texture map. So if I just scale this up until it breaks the edges, we can see that the result is roughly what we had drawn on our texture bitmap. And we can also see that if instead of scaling it to reach the edges, we can also see that if we were to move that gizmo, right, we are going to affect how those fractures are placed on our object. pretty cool, right? Alright, let's take a quick look at the edge fracture. Because this is just a quick start, we're not going to go over the settings, we're just going to see what it is that tyFlow actually does with this edge fracture mode. I've got tyPush on again, and I'm not sure we need it for the edge fracture, but we go and add the operator. The default is Voronoi. We're going to go in and do edge fracture. We are overwhelmed by all these meshes that are being shown because there's lots of them to try and make little dents and scratches in the edges, right? So we will just turn off the display of the fracturing points and everything, so that all we see is the result. And you can see that edge fracture lets you do all this cool stuff on the edges of your objects. Alright, let's quickly look at the multi-fracture bounds, which is recommended for long objects. We're not going to go into it, we're just trying to get an idea of what it does versus the others. So tyFlow MultiFracture, we put it down here below our push operator. We go into bounds because that's what we're looking at. And right now, let's just turn off the noise so that maybe we have the tiniest of noise, right? Maybe we do 3, something like that. We just have a tiny bit of noise. And we go back in here to our bounds. We can see right now we're fracturing by the length ratio and the longest axis, which is this one. If we select the second longest axis, it's now doing it long ways. So if you're doing something with wood or whatever, then obviously you can see that there's an opportunity here for something like that. And we're not getting any more slices because of this ratio setting here, right? So without going through all the settings, this gives you an idea of what the multi-fracture bounds actually does. Alright, multi-fracture Voronoi. We're not going to talk a lot about this one because as the tutorial goes on, we're actually going to be in Voronoi mode. But we go in here, multi-fracture, and it defaults to Voronoi by default. And we can just see here, let's tune this noise down a little bit here so that we can better visualize it. Let's do 30 instead, and turn off the display for a minute. And go into wireframe view. And we can see what's going on here with the Voronoi mode, right? Which is probably a mode that we're all kind of used to as far as fracturing objects. Alright, so let's take a quick look at the hole fracture. Tyson says that it's generally used to simulate erosion damage over the entire surface of a mesh, but at random surfaces. So we go in here and we select the hull, and this is what it shows by default. So we got too many fracture points to be able to visualize this, but let's just go in here and turn off these meshes for a minute so we can see what's going on. We see our original model has dramatically changed, but let's go in here to fracture hull and just decrease the number of points for now so we can see what is happening, the result. So if we just do 1, we will actually get a result because there's one plane, right, or one hull. So that'll just give you an idea of what this fracture hull mode is going to do. Alright, so let's have a quick look at the paint mode. I still got my standard setup here, and we're going to put a tyFlow MultiFracture modifier. We're going to switch to the paint fracture, and we're going to switch to the top viewport, and we'll zoom out a little tiny bit. Something like that. And now we're going to click this paint button, and this is the paint grid. So, but we're just going to paint 2 fracture lines. So we'll do one across there, and we'll do one across here. And then we will get out of paint mode and turn tyPush on, and we can see that the fractures occurred wherever we painted our lines. That's the quick start for the paint mode. So let's take a look at the MultiFracture planar mode. Now, we should be fairly familiar with this kind of setup, because we slice and dice all the time with different cutting planes and Macs. But let's go into the tyFlow MultiFracture and switch to the planar mode. And let's A, there's too many planes cutting our box up, and B, there's too much noise to show you what's going on. So let's first of all go into the noise here and just kill the noise altogether. Alright, and then let's go into the fracture planes rollout and decrease the number of planes to, right now we just do 1. Excuse me. And let's rotate this, and we see 1 flat plane cutting across our object. And that's really what the plane mode is about. And obviously you can increase and decrease the plane count, but all these settings and everything are for another tutorial, because it's a lot of depth here, right? And this is a quick start. What we can do here though is we can go into the gizmo, and we can move the gizmo around to decide where things are going to cut, and we can also rotate the gizmo and do stuff like that. So there's the quick start for the planar mode. Alright, let's have a quick look at MultiFracture radial mode. This is a really cool mode. I like it a lot, and I'm gonna have to do something with it. It also has many settings, so way beyond the scope of a starter tutorial. But let's MultiFracture here, go into the radial fracture, and you can see that from the center here it created these really cool lines, just the default settings, right? Now maybe we're a bit overwhelmed by the quantity of lines and stuff, so maybe what we can do right now is go into the radial rollout, and you can see it has many settings that are going to have to be another tutorial in its own right, but we can decrease the number of lines right now. Maybe we just do 20, and that gives us a better chance of seeing how the lines emanate out from this middle point here. And also we can go into the gizmo mode and move the fracture impact zone to wherever we want it. So I mean, that's just a really cool effect. If I turn off tyPush for a minute, you can kind of see the grid line patterns that you're going to get with this mode. It's a very interesting mode. There's a few different seed examples. I mean, look at that. That's just cool, right? So that's the 8 modes. Let's get into a little bit of theory and detail on core settings that will definitely get you fracturing pretty happily. Alright, tyFlow MultiFracture. It can be both an operator and a modifier. So there's some overlapping concepts. There's some things that are only available in the operator versus the modifier. But, you know, based on Tyson's examples, this is kind of what each mode is kind of designed for. So this is a good summary. Here's your 8 modes. You know, bounds, edge, hole, paint, planar, radial, text map, Moroni. So here's an example of what they're going to be used for. Now, there's an important kind of concept that we have to think about as far as when the fractures happen, and you know, the number of points is kind of how many fractures will happen. So if we only have 2 points, we essentially fracture the object once, right? Which gives us 2 resulting objects, right? If we have 3 points, then we kind of will get a mesh that generates 3 fracture lines, and generally so equals 3 objects. That resulting objects may change if you have, you know, some overlapping intersections, but generally speaking, the number of points is going to kind of equal the number of resulting objects. You'll say a cube would be fractured into 2 pieces here, fractured into 3 here, fractured into 4, etc., etc., going up. And we'll do a more detailed on this segment size in the next video. But density and detail, you know, segment size kind of is going to end up being the density and detail of the fracture mesh, which equals the density and detail in your fractured faces. And the noise, AB noise here, you know, that's what's going to distort our fracture mesh. So the higher the noise, the more distortion we're going to get on our mesh, and the more radical or whatever our fractured surfaces will look like. So if we start with this Voronoi mode, right, there's kind of 3 main settings that are going to give a quick start to creating, you know, beautiful fractures. So, you know, segment size is going to kind of control the level of detail in the fractures, as well as the max number of segments. And noise is going to be how we distort it. So if, for example, we have no noise set, we'll get a perfectly flat fracture mesh. All right. And then depending on the number of points is how many times we split the object, as we said over here. When we start adding noise to this fracture mesh, we start to distort the mesh, right? So no noise, we get a very flat plane, almost like you took a plane gizmo and cut it with a flat plane, right? Small noise, you'll just start to get little kind of deviations in the shape of this flat plane. And higher the noise, you know, the more this is going to distort, and the more that your fracture face is going to look wobbly and kind of all randomly cut, rather than say a flat plane. And the segment size kind of means like, it generally, if you have a segment size of 1, you know, you get a 1 by 1 matrix. If you have a segment size of 10, it's going to try and create a 10 by 10 matrix as close as it can, etc., etc. But that only works if the size of the max number of segments is set high enough to support whatever you're setting here. And I've got a good explanation of that coming up next. But I mean, this is the quick start understanding of how to make beautiful fractures. So I think there's a couple of there's many settings in MultiFracture, but I think there's a few really critical ones if you just want to get going quickly, right? And we need to understand this fracture mesh. That's what's actually going to make the cut on the surface. And right now we're looking at the size of the segment size versus the number of segments. Now, really, they can work 4 against each other over here, right? So in other words, you could have a very small segment size, but because you're only allowing X quantity of segments, you'll never see that small size arrive. So, you know, this is where they can either work for each other or against each other, right? So, like a good kind of easy starting formula would be, you know, say you want a high density fracture mesh, right? Then you will want a small mesh size, and more segments. In other words, if you're really decreasing this mesh size, you're going to need more segments to support that smaller size. Let's say you want a more simplistic kind of fracture, like a more square chunky one, then you might kind of start creeping up on the mesh size with less segments. And I kind of made a bit of a summary here, right? But more segments equals more subdivision. But that subdivision can only happen if you have a size to support it, right? If we can have, say, 1,000 segments over here, but if we have a segment size set to something like 100 on a fairly small object, then we won't get those subdivisions, and vice versa. So you really need to realize how they work for and against each other depending on how you use them. And if we just look at these examples over here, so we've got a tiny segment size, 0.01. We really should have a lot more subdivisions here, but because we've only allowed one segment, it's not happening. So here we have a larger segment size, but again, because we're only allowing one segment, we're only getting one. So, and here we've said we can have two segments. Now, luckily we have a segment size that supports it, but now you can see it actually subdivided, right? It's now a 2 by 2 matrix. So it's exponentially more segments than here, right? But here we're also saying we can have two segments, but because the size is so big, we're not getting it. So in other words, if the segment size is small enough to allow the maximum number of segments, then you'll get your subdivision you're looking for. So in this case, a segment size of 1 with maximum of 4 segments is giving a 4 by 4 matrix here, which is exponentially larger than the one above, and exactly the same in this example here where we're saying 8 segments. Because we have a segment size that's small enough to support it, we essentially get an 8 by 8 matrix. So obviously the more density of this matrix is, the more you're going to be able to manipulate the fracture surface, the more detailed you can make it look. And I think there's a case to be made for both having less, more chunky looking cuts, and then there's a case to be made for really highly detailed, very finite kind of surfaces. So, you know, basically, for one last time, if the size allows it, you're going to end up getting a matrix based on the max segments. So in other words, you know, max segments of 1 will give us 1 by 1. Max segments of 10 will give us 10 by 10. Max segments of 100 will give us 100 by 100 grid, etc., etc. So if we now kind of take a look at the number of points and how they affect it, we'll start to really understand how to adjust our fractures and make them look good, or at least make them look the way we want them to look. Alright, let's have a look at fracturing points. Easiest way to show is this kind of flat plane here, and we'll go in and put that in the right place, and we will alright, so there's no problem with starting with the Rono fracture here. We're just going to decrease the number of points per minute, which is what we're talking about. But we're also going to remove the noise, so it'll end up looking like a flat plane fracturing, so we can visualize everything much better. So we're just going to kill this noise, and now you can see that we actually have a single fracture plane. So we have 2 points, and I don't know if we go in here and show it as a wireframe, That's the two fracturing points represented as points, and you see a fracturing plane in the middle. When we go back to our settings over here, we can see that we need a minimum of 2 to create one fracturing plane. And basically you can think of it this way, is whatever quantity you have in the count here is roughly how many objects you're going to split into. So if we do 4, you can see we get this nice little zippy mesh plane that's fracturing, and we end up with 4 resulting meshes, right? If we turn off the push, that's how it would look with the push on so we can see it. And if we do something like 10, and obviously we don't have any noise to distort all that, but it makes it really easy to see what's going on. So basically, the more fracture points you have, the more objects or fracture elements you're going to end up with, one way or the other. That's fracture points. So what we're looking at here is I've got a cube split into two elements, right? It's been fractured. There's only 2 points, which gives us 2 resulting objects because we just have one fracture mesh, and it's for the purpose of visualizing what we just covered in theory. So I'm using tyPush to move these objects apart, and then I've placed the MultiFracture mesh in such a way that we can see the mesh that's generating the faces, right? So if we look over here on the right in the fracture mesh section, we can see that I've got a segment size of 1 and 40 segments. So what I was saying in theory is tyFlow will try to generate a 40 by 40 grid, right, which is exponentially more dense than a 35 by 35 grid, right? It's kind of an exponential result. So, but it will only generate those 40 by 40 grid if this segment size allows it. So for example, if I put 10 in here, we see that even though we have 40, we're allowing 40 segments, we can see that we now don't get that 40-40 grid because our segment size. So that's how you can relate these two together, right? So we go back to 1 here, so we get back to our original scene. So that'll help you to visualize this segment size versus segments. So now that we have, say, a sufficiently dense enough matrix for our fracture mesh, if we come down to noise now, and where did it pop off to? Here. So we're looking at noise A, and I had it set to 0, which results in a flat plane. So if I just start adding some noise here, 10 to start with, we can see what happens to our fracture mesh, right? It's starting to get this wobbly look, and the resulting surface we can see on our cube. I'm just going to turn off the grid, right? And we can see, so we increase this noise, say, to something like 30, right? We can, when we look at the orange fracture mesh here, we can kind of visualize how the noise is distorting our mesh and how that's adding this beautiful kind of surface to our object, right? Like if I turn off edge faces for a minute, we can kind of see the fracture surface, right? So sometimes, or maybe a lot of times, you'll want to use fracture noise and A and B together. So, you know, think as fracture noise A as your kind of rough starting setup, and then fracture noise B as your fine tuning. And the settings here generally should be smaller than the settings in A. So if I just go in here and do something like 5, we can see we're going to start adding nice little detail. And I'll look at the mesh here, and let's do something like 10 here. And now we can see we're getting quite a distortion on our mesh, and here we can see the resulting surface, right? So basically, to get yourself going in this, and control this look on the surface you want, you kind of need to, first of all, how many fractures are you going to have, which are the number of fracture points, right? So that'll be how many fractures are made on the object. And then with your segment size and your number of segments, you're controlling the density of this mesh. And then with your noise, you're adjusting the bumpiness and the look of this fracture mesh, which is ultimately what makes the cut or the shape of your fracture surface. So let me just close this down here for a minute. So we go into noise A here, and let's say I make it more dramatic, like 60, and this box disappears because it's being offset by this push operator, right? So you can see, first of all, we had a lot more dramatic noise in the fracture mesh, and if we look at the resulting surface over here, you can see that, you know, you're getting some really cool effects, right? This is like a really cool fracture. And then if we fine tune that more with the noise in B, so we got this set to 60 here, and we go up a little bit more in our fracture noise B here, right? Say something like 10. You can see you're really kind of starting to add more detail. But if we now go back to the fracture mesh here, and let's say we allow more segments than what we've been allowing. Let's say we allow 100 now instead of 40, right? Now we got a little bit maybe not so good mesh happening here, where it might kind of be oversecting and messing with our good quality faces, right? Polygons. So, you know, but because we've allowed essentially more density on this mesh, especially if we went even lower, let's say 0.8, alright, we're going to just get a more dense mesh here, and now we tweak our noise a little bit to suit the kind of look we're looking for, alright, and I need fracture noise A, let's say do 50, but anyway, the main point here is that, you know, those are the core kind of settings that's going to affect the mesh, that's going to affect your cuts. So you play with those settings, and that's how you can control how beautiful you get your cuts. For example, I sometimes like more simpler kind of fracture faces, right? So if I go down here and now say, well, I'm going to go a lot bigger on my segment size, like I'm going to go 20 on my segment size, right? So you can see how that really simplified our fracture mesh, and we just kind of got this subtle kind of surface that's fairly smooth but still has many angles to it, right? But if we just go a little bit smaller, like that's just, to me, sometimes simpler is just as good, right? It all comes down to what your taste is on your fracturing. And again, just to reiterate here, we've only got 2 points set right now, which means we only have one fracture mesh that's splitting our object into two. We increase that to 3. Now we should have 3 objects, then they're scattered around because the way that this push operator works. If I set this to 750 for a minute, we'll get them in close, and now we can kind of see our mesh here, and we can see how, I mean, that, to me, that's kind of a beautiful fracture here, right? And that's just with fairly low level settings. But anyway, you know, really you play with those 3 or 4 things that I've just mentioned, and you're going to do some crazy cool fracturing. Okay, I suppose I should have just quickly covered texturing for this quick start. So we got this cube that we did the multi-fracture on. I just added an edit poly modifier so I could go in there and select all the elements and faces and set them to material 1. So now our original box, everything has been set to material 1. what's going to happen in this tyMultiFracture thing is when we go into meshes, we see this material ID section here in the UV scale. This applies to the fractured surfaces only. So if we go into our material editor here, and I have to apply it to the object because we're doing the modifier. If I was using the operator, I would apply it to the tyFlow symbol, right? So I'm going to apply a texture to our cube. And so we can see that, and we go back to the material editor for a minute, you can see that the black checker is material 2, the blue checker is material 1, because we had everything set to 1 here, and the fracture faces material was set to 1. We have the same material being applied to both the fracture faces and the object itself, right? So just to change that, material 2 now is the black checker, right? So now I'll turn off this fracture mesh so it's not in our way and the fracture points. So now we can see that material 2 is being applied to our fractured surfaces and material 1 is on the outside. So the main point here is consider texturing and material IDs way before you get too far into any project. If we change the UV scale here, alright, then that's going to change how your texture looks on the fractured faces. Alright, so I hope that helps you get started with making something sweet. We'll do some more in-depth tutorials on MultiFracture, but I think this is a good quick starter. So let's do a super quick start example using the theory that we just covered to get us going quickly. So we do a box, we're just going to do a cube, and we're just going to do it 150 by 150 by 150, and I will center it on the origin, not that it matters. So we have our 1 by 1, we have our 150 by 150 by 150 cube. So now we're going to put the MultiFracture modifier on it. So that's the initial kind of view we get, and we go, oh, what the frig is going on? Well, what's going on is it's defaulted to 10 fractures, it's added some noise already, and it's got all the visualizations turned on. Now, at this point, I'll just turn off fracture intersections. I kind of like looking at the mesh and the fracture points. Don't really matter to me, but it gives you an idea. So if we want to visualize this result here right now, because we can't really see it until we say drop it and break it and let it land on the ground, then we can put this tyPush operator on our object, right, to help you get going. So, and we're going to say push the elements apart, and this setting will vary. You might have to go right up to 4, 5, 10, 12,000 depending on the density of your mesh. So the higher density the mesh, the higher the number is going to have to be here to push it apart. The lower the density of the mesh, the smaller the number. So I'm just going to try something like 200 and see what happens. And yeah, it's not bad. I want to visualize a little bit more, so let's do 400. So right now we'll maximize this viewport here. So right now we're looking at kind of the default tyFlow settings result on our 150 by 150 cube. But we want to kind of control this, right? So the first steps we're going to take in this quick start mode of ours is we're going to go into our settings here, and the first thing we're going to do is we're going to kill noise A and B. Make sure they're both set to 0. I'm zeroing that one out, and I'm zeroing out noise. So now we're just getting flat cuts, absolutely flat cuts, and we're getting 10 of them, right? And we can also get an idea now of the density of our mesh, which is going to be what allows the amount of detail. So in our quick start guide here, we only want 4 fractures, right? So we're going to come in here to fracture points and set this to 4. And you can see we now have 4, our object split into 4, and it's based on this mesh. So reaffirming that we want to control things, we now go into fracture meshes, roll out, and if I set max segments to 1, even though I got this segment size at 12 point whatever, we're only getting 1 segment. So really now we're absolutely getting the most simplistic, almost as if you used a slice plane 4 times, right? So even if I increase this density here, we're not seeing it on the mesh. So if we're going to try and have higher density mesh for more detailed fracture surfaces, we're going to have to allow the number of segments. So you're going to have to play with these 2 numbers in conjunction with each other to get the result you want. We're just going to turn this up and say the default, we're going to allow 250 segments. So now it's hard to see, but you can see you got, because we've got a size that supports it, you can see that our fracture mesh got really dense. So now if we apply noise, we should get a much finer result on our fracture surfaces. Let's not be that crazy for this quick start example. So we're going to set our size to 5 so we can more easily visualize. So A, we've split the object into the number of elements we want with our fracture points. B, we've removed the noise and everything so we can take it step by step. And then we can come back and tweak this later if we want. But we've set a segment size we think might work. So now when we go down to noise here and start increasing our noise a little bit, we're going to see what's going to happen with our fracture surfaces here, right? And that's the quick start guide example. I mean, I already like that result. That's a nice result to me. But if we now went into fracture noise B and just added a little bit more kind of detail, you can see how that's just really tweaking it. And sometimes I don't want all these little flakes or things or intersections that might be coming out. So this is something that you're just going to have to play with until you kind of get the look and feel you want. But I mean, to me, this is already a beautiful fracture result, and that's how easy it is to control and get a quick start guide on fracturing using the Voronoi mode.